Welcome children. Now we can discuss about from the beginning. That is the first unit about its revision. The first question to you is, what makes things visible to us? Can you remember it? What makes things visible to us? Suppose you can see this pen. How? Or you can see this stone. How? That means how we see things or object. That means we see object when light falls on it, and that light when reflected and falls in our eye. That means when an object reflects light, and that light when we receive, we can see that object. So first question you want to remember from our top: what makes things visible to us? Object reflects light, and when we receive that light, we can see that object. In our ordinary discussion, we consider about straight line motion of light. That means light is considered travel along straight line. But on the path of light, if small obstacle, opaque obstacle is placed there, then that light enters into its shadow. That shows what light wave nature also. So actually light has got the straight line motion, and also it has got the nature of what is waves motion. Now another question to you from this: what actually quantum theory says about light? Quantum theory of light says light has got the property of particle as well as wave nature. That means light has got the properties of these two, which are there on particle nature and also wave nature. So light, in our ordinary consideration, we discuss light travels along straight line, but when we discuss about a diffraction, we consider wave nature. But when we consider about what photoelectric effects, etc., we want to consider particle nature of light also. So the quantum theory of light explains light has got both particle as well as wave nature. Now another question to you: can you remember, to explain the phenomena of reflection and refraction, which nature of light we consider? When we discuss about reflection of light and refraction of light that we want to discuss in this unit, we consider light travels along straight path. That means light is traveling along straight path or straight line. Based on this idea, we explain the phenomena of reflection as well as refraction of light. Then can you remember another question to you about this one: which are the two laws of reflection? Which are the two laws of reflection that you already studied in your class 8 onwards. What is actually two laws of reflection? This, suppose a smooth and plain surface, and this one is the normal drawn to this plain surface, and if a light ray is incident, this is the incident ray, and this light reflected back, and this one is the reflector ray. Now you want to remember the two laws on this is the angle of incidence, that is angle between incidence ray and normal. Angle between incident ray and normal. That is, this is the incident ray. This is the angle of incidence, and this is the reflector ray, and this one is the normal. Angle between these two is called angle of reflection. Angle of reflection. These two are equal. That is angle I equal to angle R. That is, angle of incidence is equal to the angle of reflection. This is the first law. And second one, incident ray, reflector ray, and normal drawn to the surface at the point of incidence, they lie in the same plane. These two laws you already studied, and just once again you remember about once again, this is the angle of incidence and this is the angle of reflection. They are equal. This incident ray, reflector ray, and normal which we drawn to the surface at the point of incidence are in the same plane. These two things you want to remember about the laws of reflection. Now you can remember about this once again. See, another question to you is, the laws of reflection is applicable to all types of surface. That means these two laws of reflection is applicable to all type of surface. See, this is a plane surface. Suppose if we take this one is a curved surface. The question is this law is applicable to this curved surface also. That means here we discussed about a plane surface. The two laws, is this law is applicable in this case. That means any type of surface, the law is applicable even it is a plane or curved surface. That means in the case of plane or curved surface, this law is applicable. Now next question, what are the properties of image formed by a plane mirror? That means plane mirror which we used to see our face or which is placed in our dressing room, how the image formed by it? What is the properties of the image formed by? That means to see an object, we know light reflected from the object that we want to see. Here the question is properties of image formed by a plane mirror. Which are the properties of image formed by a plane mirror? Which are the properties of image formed by a plane mirror. That is properties of image. On it always forms virtual and erect image. Plain mirror always forms virtual and erect image. First point you want to remember. And second one, there is size of image equal to the size of the object. These two are equal. The size of the image here equal to the size of the object. Then third one, distance to the image from the mirror. Distance to the image from the mirror is equal to the distance to the object. That means, suppose if the object is half meter away from the mirror, then the image on the mirror is also half meter away from the mirror. That means, distance to the image is equal to the distance to the object. Then one more things you know, which is that these are the properties, and one more properties there. That is, image is laterally inverted. How? The image is laterally inverted. That means, in it left side appears right and right left in that way. So these are the properties of image formed by a plane mirror. Which are they? That a plane mirror always forms virtual and erect image. Then size of the image equal to the size of the object. Distance to the image is equal to distance to the object. Laterally inverted, image is laterally inverted. These are the properties. You already studied about this one. Once more, you remember these things. Now, another question to you. What do you mean by spherical mirror? Can you remember? What do you mean by a spherical mirror? Can you remember? Try to recollect it from your memory. What do you mean by a spherical mirror? That means a mirror with a curved surface, or a mirror with a part of a sphere. That is spherical mirror. What is actually a mirror? Is a part of a sphere. It is a part of a sphere, or a mirror with a curved surface. And we used to say these are the spherical mirrors, which are a mirror. It is a part of a sphere, or a mirror with a curved surface. It is called spherical mirror. Now another question to you. Which are the two types of spherical mirrors that we discussed in our class? Which are the two types of spherical mirrors? Can you remember? Try. Which are the one? is concave mirror, and another one is convex mirror. These are the two types of spherical mirrors. And in the case of concave mirror, it's a reflecting surface. Here is the reflecting surface. Curved inwards. Reflecting surface curved inwards. Reflecting surface curved inwards, or reflecting surface is towards the center of the sphere. And in the case of convex mirror, this is a convex mirror, and this is the rough surface, and this one is the reflecting surface. This convex mirror, it's a reflecting surface curved outwards. It is curved outwards. In the case of convex mirror, its reflecting surface is curved outwards. These are the two types of spherical mirror. In this spherical mirrors also, the two laws of reflection applicable. That means with plane mirror as well as spherical mirror, the laws of reflections are correct. Now, another question to you: which are the terms commonly used in spherical mirrors? Which are the terms associated with the spherical mirrors? Which are the terms associated with the spherical mirrors? First one is pole. That we use to represent with P. What is actually pole? This is the reflecting surface of the concave mirror. Its midpoint is called the midpoint of the reflecting surface, that we use to term as a pole. Pole is the center of the reflecting surface. That is the midpoint of the mirror. Here, this is the midpoint pole. Now, on term this pole of the mirror. Now, another term. That means this mirror actually is a part of a sphere. See, now this becomes a sphere. So, it has got a center. Here, it's a center. And second term is a center of curvature, used to represent with the letter C. Center of curvature. The term second one related to a spherical mirror is the center of curvature. It is the center of this sphere. See, in this sphere, this mirror forms a part. So, it is the center of curvature. That is, center of curvature is the center of the sphere in which mirror is a part. So, second term. Then third one is radius of curvature. That means radius of curvature R, or this point is P and this is C, P, C. Radius of curvature. First one, second one, center of curvature, and third one, radius of curvature. That is distance from pole to center of curvature. This distance is the radius of curvature. The third term is the radius of curvature. It is equal to R, that is also equal to PC. It is the distance from pole to the center of curvature. Then another term, this is the principal axis. Can you remember what is actually principal axis? Principal axis is the straight line passing through center of curvature and pole in this way. A straight line which is passing through center of curvature and pole. A straight line which is passing through center of curvature and the pole is called principal axis. Now, how many times we discuss the pole, center of curvature, radius of curvature, principal axis? Then see, this from here to here, it's a reflecting surface. This M represents a reflecting surface. Here also, this part M to N. Here this much part represents a reflecting surface. And the diameter of this reflecting surface, diameter of the reflecting surface is called aperture. Another term. And here it is ML. What is actually aperture? It is the diameter of the reflecting surface. Diameter of the reflecting surface is called what is aperture of the mirror. So here we discuss the pole, center of curvature, radius of curvature, principal axis, aperture. Can you remember all these terms? There is one more term that is also related to this spherical mirrors. That is the principal focus. In our class, we discussed about how to find focus of a concave mirror. Can you remember the activity we discussed? That means we discussed about the activity light from the sun is allowed to fall on a concave mirror and it is allowed to fall after reflection on a sheet of paper by adjusting the distance from the mirror. Make a bright spot on the paper. That means this is the light from the sun, that is sunlight which falls on this concave mirror, and when this light after reflection falls on a sheet of paper, adjust the distance to this paper to the mirror. When by adjusting we can get a bright spot on the paper. That bright spot is the image of the sun. That bright spot we got on this paper is the image of the sun. And after keeping that image is actually in its focus. That image is formed in its focus. So we get a focus of this concave mirror. And the distance from this focus to this distance from this focus to this concave mirror gives focal length. That means here suppose we got a bright spot, that means image of the sun, then the distance from here to this mirror gives the, that means focal length, gives the focal length. By keeping this paper for some time, what happens? This paper starts to burn. This paper starts to burn. So in this way we can find the focus of this concave mirror, and also we get the approximate focal length of this mirror. We get approximate nearly equal focal length we get from this. Now here there is one more point we want to know, that is the focal length. See, this is a concave concave mirror. It's a fold. This one is its principal axis. Light rays parallel to this principal axis and also close to the principal axis. These are the light rays parallel and close to the principal axis. After this rays reflection, it meets at a point or passes through a point on the principal axis. That means these rays parallel to the principal axis. After reflection, these will meet at a point or passes through a point on its principal axis, and that point is the principal focus. That point is called principal focus, and it is represented with a capital F. Now the distance from pole to focus, that means speed F, that is equal to focal length F. This distance P to F, it is the focal length. It is actually what is the focal length. This is the principal focus of a concave mirror. And in the case of convex mirror, see, this is a convex mirror, this is its principal axis. These are the light rays parallel to the principal axis. See, after reflection, these rays appears to come in. When we extended it in the backward, see, these are appears to coming from a point on its principal axis, and that point is the principal focus of convex mirror. So in this way we can get the principal focus of concave mirror as well as convex mirror. Once again, how? So you should remember how to draw this. That means this is the principal axis. These are the rays parallel to the principal axis. After reflection, what happens to these rays? These rays meet at a point or appears to passing through a point on this principal axis, and that point is the principal focus. And in the case of convex mirror, these rays parallel to the principal axis. These rays after reflection appears to coming from a point on its principal axis, and that point is the principal focus of this convex mirror. So these are the points that we want to remember about. These are the points that we want to remember about the mirror when we discuss about the terms associated with a spherical mirror. Can you remember all these terms, sir? Which are they? Try to remember once again. Which are they? Pole, center of curvature, radius of curvature, aperture, principal axis, principal focus, focal length. Now, for you, another question. What is the relation between focal length and radius of curvature of a spherical mirror? Relation between focal length and radius of curvature of a spherical mirror. For a spherical mirror of small aperture, for a spherical mirror of small aperture, this radius of curvature is equal to twice of focal length, that is R is equal to 2F, or F is equal to what we get? R is equal to 2F, then F will be equal to R by 2. F is equal to R by 2. That means in the case of a concave or convex mirror, we know this is pole and this is the radius of curvature. So, where will come this focal length? This focal length is in between, that means midpoint of these two. That is the midpoint of central curvature and pole is the what? Focus, that means principal focus. So this distance, that means principal focus lies in between the midway of central curvature and pole. Hence F is equal to R by 2 or R is equal to 2F. Can you remember this? That we discussed in our previous class. Now you want to remember once again for our exam point of view. Now, how the image formed by spherical mirrors, we can discuss with some activity. Here we require a concave mirror, candle, mirror stand, screen. First of all, makes a straight line on the table. Place the lens, that is mirror stand, on this line. Before doing that is first of all you draw a line on the table and place the mirror stand on this line in such a way that when we place the mirror on this stand, its pole should be in this line. And before doing this activity, you should find its focal length by using distant object or by using the activity we discussed earlier, that is by using sunlight. And to draw two more lines parallel to this one, which are at a distance of F and 2F. That means here is C, here is principal focus, and here the mirror pole in this way. At first, you place the object at a very large distance, or try to get the image of a distant object on this mirror and allow it to fall on the screen placed on the same side. That is, at first we do object at infinity. Where is the position of object? Object is at infinity. Then position of the image, where will be at F. That means when the object is at infinity, we get an image at the focus. Then size of the image is very small or diminished. What type of image we got on the screen means very small or diminished. And nature, it's a real and also inverted. We get a real and inverted image. Now we place this is the C. Now the object, that is object here is the lighted candle. That you place just behind the center of the image. Now the candle is here. Again, try to find image of this candle on the screen. Now, second case, object where it is behind C. Then position of the image is in between this F and C. Image is small. We got small image, and it is also a real and inverted. Real and inverted. Now place the object at C. That is, here the lighted candle is on the line where we mark the C. Now again try to get the image of this one. Where we get the image? We get the image at C itself. That means we get the image here. Here is the image. That means now third case, object at C. Object position is at C. Where is the image position? It is also at C. Then size of image means same size. Here also real and inverted. Image is real and inverted. Now, fourth, again you do this activity. Place the object in between C and this is F. Now, the lighted candle is placed in between C and F. Where we get the image now, that is now the object is between C and F. Where we get the image, we get the image behind this one. That means here we get it, that is behind the C. That means here is the image is getting. So the image is behind C. And size here is large size. That means compared to this object, the image is bigger one. Here also it is image is real inverted. Real and inverted image is getting. Now fifth, you place the object at F. Here is the mirror is set. Now object is at F. Where we get the image. Now the object is at F. Focus. Then the image is getting at infinity. Then the position of image is at infinity. That means when the image is at infinity, the image size is very large. Real and inverted image is getting there also. Real and inverted image is getting in this case also. Now we are going to place the object between this F and the pole. That means object is in between these two. That means light time is placed there. Then we cannot get that this image is when the object is at where is the position of object between F and P? When the object is in between F and P, see that here is the position of object. Then the image is not getting on the screen. Now we can see the position of the image. Now we can see the image on the mirror. That means the image will get behind that means we cannot get it actually on the screen, but we can see that image and its position is behind the mirror. So object is between F and P. Position of the image is behind. Here image is very large, but the image in this case is virtual and erect. Virtual and erect. So the image in this case we got virtual and erect when we place the object in between focus and pole. In all other cases we got real image only. But in between pole and focus, if we place an object, then the image will be what? Virtual and erect. So a concave mirror forms virtual image only when an object in between pole and focus, and that image is enlarged one. Enlarged means that image is very large and it is virtual also. Now from our revision we discuss about how a concave mirror forms image. Now with this all we can wind up this class. Okay.